Okay, today we're going to look at the law of sines. And the law of sines is a useful tool to solve for missing angles and sides of non-right triangles. So for the past few weeks or whatever, we've been using right triangle trigonometry. We've been using SOHCAHTOA. But you can only use that when we have a right triangle. And as you know, in the real world or in geometry, when we come across problems, they're not always going to be right triangles. So the law of sines says that the sine of angle A divided by A is equal to sine of angle B divided by B equals sine angle C over C, which probably doesn't mean much to you, but if we draw a triangle, we can now see our angles and sides. So we label our angles A, B, and C, okay, A, B, C. And then to find the sides, we go straight across from the angle. So straight across from angle A is going to be side A. Straight across from angle B, we have side B. And straight across from angle C, we have side C. So it doesn't matter if they give us a triangle, if they don't give us one. We should be able to label the sides, create our own, and draw it. Okay, you're always going to have sides ABC, and then, angles ABC, and then the sides are going to be directly opposite it. So, and in that scenario, the capital letters are your angles. Okay, so capitals are angles, and then the lowercase are going to be your side lengths. When you solve a proportion, okay, so this looks intimidating at first because you have two equal signs and you have three fractions going on. You are only going to use two of the fractions at a given time. So you figure out what was given to us, what we want to solve for, and you're going to pick two of the fractions and leave the third one alone. We're going to put that into practice right now. So using the law of sines, we want to solve for a missing side in this triangle. So I look at the triangle. We have 35, 105, and 40 degrees. And they went ahead and already labeled the angles A, B, and C. My first step solving this triangle is to figure out, hey, can I find the missing angle easily? And it turns out on this problem, which it's not the end of the world, we didn't need it, but it turns out since they gave me two of the angles, we can find the third one easily. We still know that the angles of a triangle add up to 180 degrees. So we have 35, 105, 40 add up to 180 degrees. With your angles, we're going to go ahead and throw them up top in our table. Okay, so I gave you a table on this one, but if you have to make your own, we're going to throw angles up top. So I went ahead and threw in for angle A, B, and C up top. Down below are going to be the sides. In this triangle, the only side they gave me was side B. And again, I know it's side B because if I draw a line coming straight out from that angle, B, the side it hits is going to be side B. You can say the same thing for A too. If I draw a line straight out from A, the side that it hits is going to be side A. And then here you already see that C goes with C. So finishing up the table. Didn't give us A, I don't care about A. They gave us side B is 7, so I go ahead and throw the 7 next to B. And then side C is the one I really want to solve for, so I went ahead and threw a question mark next to side C. Okay, next thing we're going to do is we're going to put a star by the two things that we have. So you're either going to have both of the A's, you're either going to have both of the B's, or you're going to have both of the C's given to you. For this problem, I know the measure of angle B, and I also know the side length for B. So I went ahead and put stars next to each of them to let me know, hey, that's what I'm going to work with. And now we start plugging into our formula. So up top, we had this sine A over A, sine B over B, sine C over C. I'm going to go ahead and do sine B over B. Okay, we have the sine of 35 degrees. I put it over my side length, which was 7. Okay, so that's the first part to actually solving this. For 3, they want us to finish our proportion by using the other information. So looking at my other information, I want to solve for C, and they gave me angle C. So I'm going to work with those. You have sine 105 degrees over side length C. The last thing we have to do is actually solve this. Okay, so if we go about solving it, you go up to your formula. We picked the B and C, so I'm going to forget A. Okay, we're just going to say sine B over B equals sine C over C. So that's what I have right here. Sine B over B equals sine C over C. And then we would solve it just how we would any other type of problem. Remember, your first step is to bring the denominator up to the other side. So I have C. I went ahead and bring it up to the left. I brought my 7 up to the other side. And then from there, I don't have C equals. Okay, so originally, like, we're left with this right here. I don't have C equals, so I go ahead and divide each side by sine 35. And when I do that, I'm now left with C equals. And you just go ahead and plug that in your calculator. As always, make sure the calculator is in degree mode. You're not going to deal with radians until later. So you hit mode, make sure degree is highlighted. And then you type in exactly how it looks. So you're going to have 7 sine 105. 105. So 7 sine 105. Make sure you close out the parentheses on that one. And then divide sine 35. When you do that, you get 11.788. We're still rounding to the tenths, so I'm going to knock that up to a 0.8. Okay, so that's one type of problem right there. I'm going to do one of the practice problems as well, just to show you how you can solve the full triangle. Okay, so number 1, on the next side. First thing you're going to do is go ahead and label or fill in the table. Okay, so in my table, I had C is 63 degrees. Okay, so I didn't have A or B yet. And then I had 2 of my sides. I had side B and I had side C. Okay, so you go ahead and fill in the missing information. From there, you put a star next to the 2 things we were given. So we were given angle C, we were given side C. And then from there, we start like using our skills. Okay, so I went ahead and solved for angle B first. So I have sine 63 over 5.5 equals sine B, because I don't know the angle, over 4.7. From there to solve, you go ahead and bring the 4.7 up to the other side, which we did. And then we're trying to solve for an angle here. So you remember, like, from a week or so ago, when we solve for an angle, you have to make sure you have -1. So on our calculator, I'm going to type in exactly how it's written right here. I'm going to go second sine 4.7 sine 63, close the parentheses, and then divide by 5.5. And it gives me 49.6 degrees. Okay, so I'm able to go ahead and throw 49.6 degrees up into my table. From there, I can solve for angle A because I know the 3 of these have to add up to 180 degrees. So I do 63, 49.6, 67.4. They all add up to 180, so we're good to go from there. Then there was one last thing I needed to solve for, and it was side A. So from there, I went ahead and picked the 2 things that I was given originally. So sine 63 over 5.5 equals, I just found the measure of angle A, so sine 67.4 over side A. And then we solve it much like we did on the first example I did. You bring the denominators up to the other side, and then it's not A equals yet, so you go ahead and divide each side by sine 63. It's going to give you A to equal 5.7. So, law of sines you're going to use, or you could possibly use whenever we don't have a right triangle. Remember, like, you cannot use SOHCAHTOA. You cannot if we do not have a right triangle.